Rational and irrational numbers. This is a digital lesson, and the lesson starts with explaining to students that a rational number is any number that can be expressed as a fraction. So these decimals are rational because they're equivalent to fractions. These three at the bottom are irrational. So how do they identify an irrational number? Well, first, decimals that go on forever and do not repeat are irrational. For example, pi. So pi is irrational. Square roots and cube roots that are not perfect squares or perfect cubes are irrational. So all the natural numbers, whole numbers, and integers can be expressed as fractions, so they are all rational. So for example, the number 1, it can be expressed in many different ways as a fraction. The integer -5 can also be expressed as a fraction. So these are all rational numbers. And students on slide 5, they're going to type in examples of fractions so that they can show that all of these integers are rational. So for example, they could type in 9/1. Here they could have 3/1 or 9/3. So there are many different possibilities here. They just have to type in an equivalent that's a fraction. Decimals are rational. They can be expressed as fractions. So for example, 75/100 can be written as 3/4. It can be written as 9/12, -6/8, etc. So those decimals are all rational. So students are going to do the same thing here. They're going to express these decimals as fractions. So there could be many different answers here. Repeating decimals are also rational because they can be equivalent to fractions. So all of these repeating decimals are fractions. And students are going to show this on the next slide. So they're going to take their calculator. They're going to take 1 divided by 9 here, and then they're just going to type in the repeating decimal. 5 divided by 6, 4 divided by 9, and show that those are rational. And then they're going to be shown how to change a repeating decimal to a fraction. And there are several steps, so this is a little bit tricky. So you want to go through the steps with the students. And then here's an example of how that works, following the 6 steps. And then they're going to do 2 on their own. Now, decimals are irrational if they go on forever and they don't repeat. So these are all irrational. Square roots and cube roots are irrational if they're not perfect squares or perfect cubes. And these are all irrational. This one at the bottom is an example of a rational square root. It's a perfect square, it equals 6. So it's rational. And then on the next slide, students are going to put an X next to any of these that are irrational. If they're not perfect squares or perfect cubes, they are going to be irrational. And then students need to know that if they multiply or divide an irrational number by a rational number, it's still going to stay irrational. Now they're going to put an X next to every irrational. So they've got some fractions in here, some decimals, some square roots, and cube roots. And then they're shown how to compare and order irrational square roots. So where would we place these irrational square roots on the number line? So for example, we have the square root of 28, and it's irrational. It's not a perfect square, but we know it would be between the square root of 25 and the square root of 36, 2 perfect squares. So that would place it between 5 and 6 on the number line. And so the next slide, students are going to be writing these square roots, these perfect squares, and they're going to that would be on either side of these irrational square roots. So for example, square root of 72, it would be between the square root of 64 and the square root of 81, between these 2 perfect squares. So that means on the number line, it's going to be between 8 and 9. They're going to do that with the rest of those. And then here they're going to type the whole numbers that it would be in between. So where exactly on the number line would we place these? So here we've got the square root of 25, which would be 5. and it's in between that and the square root of 36, which would be 6. So on the number line, this is going to be between 5 and 6. And then the very last slide, students are going to drag and drop each of these irrational square roots into the correct place on the number line. So that is a digital lesson, rational and irrational numbers.